Land use, natural resources, and energy. As a human populations grow, demands on natural resources continue to intensify. Land use and environmental policy must keep pace with ever-changing science, economics, technologies, and resource conditions with attention to climate change implications. Our environment provides us with a variety of goods and services necessary for our day-to-day lives. These natural resources include air, water, soil, minerals, along the climate and solar energy, which forms the non-living or abiotic part of nature. The biotic or living parts of the nature consist of plants and animals, including microbes. Plants and animals can only survive as communities of different organisms, all closely linked to each in their own habitat, and requiring specific abiotic conditions. Thus, forests, grasslands, deserts, mountains, rivers, lakes, and the marine environment all form habitats for specialized communities of plants and animals to live in. Interactions between the abiotic aspects of nature and specific living organisms together form ecosystem of various types. Many of these living organisms are used as our food resources. During the last 100 years, a better health care delivery system and an improved nutritional status has led to rapid population growth, especially in the developing countries. This phenomenal rise in human numbers has, in the recent past, placed great demands on the Earth's natural resources. Large stretches of such as forest, grassland, and wetlands have been converted into intensive agriculture. Land has been taken for industry and the urban sectors. These changes have brought about dramatic alterations in land use patterns and rapid disappearance of valuable natural ecosystems. The need for more water, more food, more energy, more consumer goods is not only the result of our greater population, but also the result of overutilization of resources by people from the more affluent societies and the affluent sections of our own. Earth resources. The resources on which mankind is dependent are provided by various sources or spheres. The first one is the atmosphere. The atmosphere forms a protective shell over the Earth. The lowest layer, the troposphere, the only part warm enough to us to survive in, is only 12 kilometers thick. The stratosphere is 50 kilometers thick and contains a layer of sulfates, which is important for the formation of rain. It also contains a layer of ozone, which absorbs ultraviolet light known to cause cancer and without which no life could exist on Earth. The atmosphere is not only uniformly warmed by the sun. This leads to air flows and variation in climate, temperature, and rainfall in the different parts of the Earth. It is a complex dynamic system. If its nature is disrupted, it affects all mankind. Most air pollutants have both global and regional effects. The growing number of scooters, motorcycles, cars, buses, and trucks, which run on fossil fuel, petrol and diesel is a major cause of air pollution in cities and along highways. Air pollution leads to acute and chronic respiratory disease such as various lung infections, asthma, and even cancer. The next one is the hydrosphere. Hydrosphere covers the 3/4 of the Earth's surface. A major part of the hydrosphere is the marine ecosystem in the ocean, while only a small part occurs in a fresh water. Fresh water in rivers, lakes, and geysers is perpetually being renewed by a process of evaporation and rainfall. Some of this fresh water lies in underground aquifers. Human activities such as deforestation create serious changes in the hydrosphere. One of the land is denuded of vegetation. The rain erodes the soil, which is washed into the sea. Chemicals from industry and sewage find their way into rivers and into the sea. Water pollution thus threatens the health of communities, as all our lives depend on availability of clean water. This once plentiful resource is now becoming rare and expensive due to pollution. Let's proceed to the lithosphere. The lithosphere began as a hot ball of matter which formed from the Earth about 4.6 billion years ago. About 3.2 billion years ago, the Earth cooled down considerably and very special event took place. Life began on our planet. The crust of the Earth is 6 or 7 kilometers thick and lies under the continents. Of the 92 elements in the lithosphere, only 8 are common constituents of crustal rocks. Of these constituents, 47% is oxygen, 28% is silicon, 8% is the aluminum, 5% is iron, while sodium, magnesium, potassium, and calcium constituent is 40% each. Together, these elements form about 200 common minerals compounds. Rocks, when broken down, form soil on which man is dependent for his agriculture. Their minerals are also the raw materials used in various industries. The last one is the biosphere. This is the relatively thin layer in the earth in which life can exist. Within it, in the air, water, rocks, and soil, and the living creatures form structural and functional ecological units, which together can be considered as one giant global living systems that of our Earth itself. The simplest of this ecosystem to understand is a pond. It can be used as a model to understand the nature of any other ecosystem and to appreciate the changes over time that are seen in every ecosystem. The structural features of a pond include its size, depth, and the quality of its water. The periphery, the shallow part of the deep part of the pond, each provide specific conditions for different plant and animal communities. Renewable and non-renewable resources. Non-renewable resources, these are minerals that have been formed in the lithosphere over millions of years and constitute a closed system. These non-renewable resources, once used, remains on Earth in a different form and unless recycled become a waste material A renewable energy system uses resources that are constantly replaced, are usually less polluting. Examples include hydropower, solar, wind, and geothermal energy from the heat inside Earth. We also get renewable energy from the burning trees and even garbage fuel and processing other plants into biofuels. Energy resources. One is the solar energy. In 1 hour, the sun pours as much energy into the earth as we use in a whole year. If it were possible to harness this colossal quantum of energy, humanity would need no more source of energy. Today, we have developed several methods of collecting this energy for heating water and generating electricity. Biomass energy. When a log is born, we are using biomass energy because of plants and trees depend on sunlight to grow. Biomass energy is a form of stored solar energy. Although wood is the largest source of biomass energy, we also use agricultural waste, sugarcane waste, and other farm byproducts to make energy. Solar thermal electric power. Solar radiation can produce high temperatures which can generate electricity. Areas with the low cloud levels of cover with little scattered radiation, as in the desert, are considered most suitable sites. Next is the biogas. Biogas is produced from plant material and animal waste, garbage waste from household, and some types of industrial waste, such as fish processing, dairies, and sewage treatment plants. It is a mixture of gases which includes methane, carbon dioxide, hydrogen, sulfide, and water vapor. In this mixture, methane burns easily. With a ton of food waste, one can produce 85 cum of biogas. Once used, the residue is used as agricultural fertilizer. Next is the tidal and wave power. The energy of waves in the sea that crash on the land of all the continents is estimated at 2.23 million megawatts of energy. From the 1970s, several countries have been experimenting with a technology to harness the kinetic energy of the ocean to generate electricity. Geothermal energy. Geothermal energy starts with hot, molten rock called magma deep inside the earth which surfaces at some part of the earth's crust. Geothermal energy is nearly as cheap as a hydropower and will thus be increasingly utilized in future. However, water from the geothermal reservoirs often contains minerals that are corrosive and polluting. Geothermal fuels are a problem which must be treated before disposal. The last one is the nuclear power. The nuclear reactors use uranium-235 to produce electricity. Energy released from 1 kilogram of uranium-235 is equivalent to that produced by burning 3,000 tons of coal. Although the conventional environmental impacts from nuclear power are negligible, what overshadows all the other types of energy sources is that an accident can be devastating and the effects last for long periods of time.